Okay, let's say we have a rectangle whose perimeter is 400. Then we want to understand how, if we know the width, we could find the length. And we want to do that symbolically. Now, can you begin by just finding a few lengths and widths that would give you a perimeter 400? Okay, well, hopefully you were able to do that. Now, I'm going to be a little more specific. If the width is 50, then what's the length have to be if the perimeter is going to be 400? You should work that out before you watch me do it. Well, your answer was almost certainly 150. The question is, how did you get that answer? There are a couple of ways to get the answer. You could say that, well, if you got 50 here, then you got 50 here, so that your perimeter of 400 leaves you, okay, if your perimeter is 400 and you got two sides of 50, the two sides of 50, just decided on words here, and I don't like the way this is going. I wrote the word then, and that then I can finish it in any coherent manner. Two sides of 50 take up 100 of the 400, leaving 300 for the two lengths. Thus, length equals 1/2 of 300 equals 150. Perfectly good way to reason that out. And if you're doing it mentally, doing it in your head, that could well be the most efficient way for you to think through it. Less formal than what we want in order to get a symbolic representation, but still a good way to think about it. Or you could think, well, one length and width are going to add up to half the perimeter, so that the length and the width add up to 200. If the width is 50, that leaves 150 for the length. Well, I'm going to write that out, but off camera. Okay, written it out. One length and one width are half the perimeter, so and that adds up to 200, so a width of 50 leaves you 150 for the length. Now, a little more formally, we could say that the perimeter is twice the length plus twice the width, or 400. And then we could solve for the width. Actually, we want to solve for the length. Go off camera for a second, fix that. Okay, so we get length is 200, 400 minus twice the width over 2, which of course is 200 minus the width. Now, I assume you can solve this equation for L. If you can't, then you need to do some heavy-duty review to get up to the point where you can really understand what we're doing here. Okay. So, another way, of course, is that width plus length is 1/2 of 400, which leads you very quickly to length equals 200 minus width, etc. Many ways to get this. Okay, so I've just transitioned from a specific width of 50 to finding the expression for the length when the width is just anything. Okay, any width. Of course, width can't be over 200, otherwise you'd have a negative length. So the domain of this variable w is 0 to 200. So we can replace the 50 here. Well, we won't replace it. We'll put width here, and we'll put 200 minus the width here. Now we want to get an expression for the area. So what is your expression for the area in terms of what we have? In terms of W, what's the area of this rectangle? You should, again, pause and figure this out, but here we go. Area is length times width, which equals 200 minus W times W, which equals 200W minus W squared. And now we want to ask the question, how do you get the maximum area? Okay, well, we're going to look at various methods for getting the maximum area. They all amount to the same thing, but we're going to see a good variety of mathematics involved and the mathematics of quadratic functions.